Hi, everybody. I'm BJ. I'm the genealogy librarian at the Maine State Library. And tonight I'm going to talk about something that's really popular today, which is DNA tests for genealogy. So let's get right into it. I'm going to share my screen. Where is it? There we go. And Kat, I can't see around you. Hey, move. Yeah, you get real life here. No. And okay. So you guys should have my PowerPoint. Good. Okay. So genetic genealogy is the fancy way of saying using DNA testing in combination with traditional genealogical and historical records to determine the relationships between individuals. Okay. We're not doing a spit test in isolation because that won't tell you all that much. So what's DNA? It's a chemical with a whole bunch of nucleotides in the nucleus of the cell that's got the genetic information about an individual. I'm not going to get too heavily into the science of this, partly because I'm not a scientist, and partly that for the most part, what I'm going to talk about, you don't need to know the details. I'm going to tell you what you need to know about the two types of tests. But basically, these DNA tests measure various components of your DNA, and the more you share with somebody else, the more closely you're related. The less you share, it means there's been more changes since you had a common ancestor, so you're more distant related. Does that make sense to everybody? So what do we have here? So DNA testing is used these days for two main purposes. One is for genealogical stuff, and the other is for law enforcement. So for genealogy, it can confirm or refute a paper trail. You know, if you've got a solid paper trail on somebody, the DNA test can say, yeah, this is right. On the other hand, sometimes the parent on the birth certificate isn't who the biological parent is. Or if people have assumed that two people with the same name are the same person and they're not, the paper trail, it's not that anybody's been deceptive at that point, but the paper trail can say, no, these two families that happen to have the same surname in the same county in Virginia or Maine actually aren't related. People use it for finding family members, either families they lost contact with or family they didn't previously know about. Adoptees are using it for health reasons, finding out if they have certain genetic predispositions to disease, finding out who their birth family was, and there are other people who know that they had a sibling or other person who was adopted to another family to try to find that out. And the final one, called non-paternal events, I'm going to talk more on the next slide. And I'm going to briefly mention the law enforcement and then come back to it next week after we've gone through this, so you have a better understanding of what they're actually looking at. And they use it for identifying unknown victims, Jane and John Does, and for identifying offenders. And so that's a very new use within the last 2 years. And so there are some issues with that I'll talk about next week. So as I said to start with, it assists traditional paper-based genealogy research. It doesn't replace it. You're going to get your best results if you've done the paper research as well. And as I said, if you've got a weak paper trail, if you have two people with a common surname, who settled in a town in Maine in the 1820s, and you don't know if they're related, it can help you figure that out, or it can say, no, they're not, if people have assumed that they were brothers and they're not. And the other big one is don't do it if you aren't prepared for surprises. Most people, I don't want to say most people, but many people are finding a surprise. Sometimes it's misattributed paternity or other parental. There are people who have found out they were adopted that they didn't know that because there'd been a reissue of a birth certificate with their adoptive parents as their parents, because that's how it was done in the middle of the 20th century. More than misattributed paternity, I'm finding people are finding, probably just because there are twice as many of them, misattributed paternity, grandpaternity. In other words, a lot more, I'm finding more people who are finding out that one of their grandfathers wasn't who they thought it was. And I think there's a combination of, first of all, there are twice as many chances because you have two grandfathers and one father. The further back you go in the 20th century, the more there was, in a lot of places, a need to cover up a pregnancy out of wedlock. And that's close enough that it's easy to figure out that there's something wrong. You're not going back, 5 and 6 generations where the amount of data is huge. So it's easy to see in a way that, your third great grandfather might not be. The other thing I'm finding as I work with patrons is a huge number of people who are finding out that they had an unknown half-sibling. I've worked with almost a dozen people in the last 3 years who found out that they had a half-sibling they didn't know about doing this. And in a lot of those cases, it's people, baby boomer era, and they're finding that one of their parents in the World War II years in particular, lived somewhere, went into a big city to work in a factory, or went into the military, World War II, had a child, and then went back to the town they grew up in, and now that child who was adopted out has done the test to find the health information, and suddenly the patron I'm working with finds that they have almost always it's an older half-sibling that they weren't expecting. So that's the biggest surprise that I'm dealing with, even more than the grandparents, is finding the unknown half-sibling. So that, just so you know, people are finding that. Sometimes you don't need a DNA test. You're related. I figured, after that sort of grim look at what can go wrong with a DNA test, I needed to make you laugh before I go on, right? I growing up, I look like my father's side of the family. My dad's sister and I, at the age of 9 or 10, there are pictures of us, and you can tell that we are related. But, so just had to inject a moment of humor. So anyway, here's an interesting bit of a case study. And what I'm hoping is that I'm going to talk about this, and then by the end of next week's program, you'll understand what I'm talking about, even though you won't in the next couple slides right now. So this is a man who died in Cleveland in 2002, named Joseph Newton Chandler III. He'd been born in Buffalo, died in Cleveland, left $70-some thousand in a bank account. So there was a reason to find out who he was, because somebody was going to inherit, $70-some thousand. Make sense? Well, they realized when they went to look for him that actually Joseph Newton Chandler III had died in Texas in 1945. And so this man had stolen this child's identity and appeared in Cleveland in the late 1970s using this name. And they realized when they went digging that there wasn't any record of who he was before he shows up in Cleveland. I think it's about 1978. So who was he? So it turned out that a hospital had a tissue sample from not long before he died. He'd had a medical procedure done, and they had some tissue of his. And so at the time, there was really only Y-DNA being done, which looks at the straight paternal line. And that, and a woman who was very early doing the genetic genealogy looked at that and predicted that he would have the last name of Nicholson, Nicholas, or a variant like that, that his close matches had names like that. Well, eventually, autosomal DNA became available, and they discovered that by looking at his relatives and then doing the paper follow-up, that his name was Robert Ivan Nichols. And he'd left his family, so you know, the Y-DNA had predicted the right general family of surnames, and this man evidently had walked out in his family in the late 60s in Texas, and a decade later had walked into Cleveland. Nobody knows where he was the 10 years in between, and started a new life. But you know, the DNA test, so this is the, you know, I talk about law enforcement using it for unknown victims. This guy was actually, I can't remember whether he died naturally or if it was a suicide, but it was not a foul play case. But they were able to identify him from that. So let's talk about the magic of how they did this. There are 3 different types of DNA tests that are done these days. Mitochondrial DNA is passed from women to both of their children, both boys and girls. Y-DNA is passed from father to son, and only men have it. Autosomal DNA is passed from both parents to all their children. So here's a representation of your chromosomes, which is what make up 23 chromosomes make up your DNA. 22 of them are the autosomal, and they're numbered 1 through 22. And as you'll see, the scientists studying this were really creative. And the longest chromosome is number 1. The next longest is number 2, then 3, down to the short ones at 21 and 22. And what happens is when a baby is made, each baby gets half of their chromosomes from each parent, but each child they have gets a different slice of what their parents have. You know, so picture if you've got M&Ms and the father is all red M&Ms and the mother's all yellow M&Ms, and you pull out equal amounts from each and put them together, that's going to be what happens. Well, then your sibling comes along and they've gone back in and pulled out the same number of M&Ms again from each, and you're going to get some of the same ones, but you're also going to get different ones. And so this recombines for every child, so every generation, okay? So on average, you will share about 50% of your chromosomes with your siblings. Unless you're identical twins, and then it's really close to 100%. And identical twins can throw the whole process off. So at this point, forget that they exist because they're just going to confuse us, okay? You do then also have the 23rd pair of chromosomes is the X and the Y. The X is from your mother. Girls get an X from their mother and from their father. Boys get an X from their mother and a Y from their father. Okay, and you can look at the X chromosome, and like with the mitochondrial, it's not used that much. The inheritance pattern's a little hard to follow, and I'll talk a bit more about so here's a summary of the 3 types. With the Y-DNA, they look at a series of what are called markers, where they basically sample at different points on the Y-DNA and look at how closely you are. And what you're looking there is, so if you test with 67 markers, which I think they're discontinuing that test. So let's say you tested 111. The closer you are with a match to sharing all 111, the more closely you're related. So you're looking for somebody where and they talk about the genetic distance equals the number of steps different. And so with the genetic difference, you know, at 111, if you share 109 chromosomes, you're reasonably related. Whereas if you only share, 93, you're a whole lot less related. And each of those genetic distance steps is a sign of a change in the DNA. That's what they're measuring. And so when the markers are the same, you share them. When they're different, it's a step of genetic difference. So I said mitochondrial goes from a mother to all her children. Y-DNA changes at a rate that you're looking at several hundred years. Mitochondrial DNA changes much more slowly. And so it's much harder to use and right now it's easier to eliminate, to say that you two people aren't related. Because if you're a match on the mitochondrial DNA, your most common ancestor between 2 people could still be 1,100 years ago, and that's outside of genealogical time. Autosomal DNA, the 22 pairs, it's measured in what's called centimorgans, and they will talk about segments, which are chunks of centimorgans. So we'll see this later when I get into some of this with charts. But basically what happens is, you'll say, okay, you've got this clump of 30 centimorgans you share with somebody and this other clump of 17. And so you share 47 centimorgans in 2 segments. And again, the more you share, the more closely related you are. And then the 23rd is the X and the Y. But basically on all of these, the more you share, the more closely related you are. So here's the inheritance pattern. And you can see for the Y-DNA, it's looking at it's the son, the father, grandfather, great-grandfather, and so on. And for the mitochondrial DNA, it's both children, mother, grandmother, great-grandmother. But the daughter is getting an X from her mother and an X from her father and has no X, because that's what makes a male is to have the Y. And so you'll notice on this, before you get too far back, you're not testing very much of the DNA, because all of these people here in the middle, any of their contributions are not coming through in this. Does that make sense? Whereas with the autosomal, it's looking at what you got from all of these people, because it's those other 22 chromosomes that have mixed and matched. So one way to think about it, I heard this description in a webinar and it's great. Think about Y-DNA and mitochondrial DNA as lasers. The light goes a long way, but it's really tiny. Does that make sense? Whereas the autosomal is like a floodlight. Because of the mixing and matching, it only goes back about 5 to 7 generations, but it catches almost everybody, and it's really broad. Does that make sense to people, that difference? Okay.
Yes.
Good. So just to look at this again, this is with autosomal DNA, and this is a case that was in one of the DNA groups I'm at Facebook, and a family actually had 6 generations to test, which is pretty impressive right there. And so because of how they do the testing, basically they look at half your, they're saying, the self has actually twice as much DNA, but they share, everything that the child got from one parent, they share. So it's a complete match. The grandchild, instead of getting half their DNA from the original person, has a quarter, because there are now 4 grandparents, not 2, like there are parents. And so they get 25% approximately, because there can be mixing and matching at this point, because what they get from their parent may not be even, because it's been jumbled up again. And so they may get more from one parent that the parent got from one of the grandparents. And so the reality is it's 22 to 27% per grandparent, but it'll add up to 100%. The great-grandchild gets an 1/8, and then 16th and 32nd. And to show you what this looks like more graphically, for those of us who see numbers and freeze, whoops, that's not what I wanted to do. Sorry, I hit the wrong. Let me get back to where I want to be. So here's a nice representation. So obviously the parent in this case, the original person in the 6th generation, has all of their DNA. The child has the green DNA from this parent and the yellow from others. And then the grandchild has the green DNA from the grandparent and the parent, and yellow from others. And as you can see, as you get further down, you get more and more yellow from other people other than this ancestor. Does that make sense? Because, by this point, you're getting, let's see, 2, 4, 8, 16, 32 people contributing DNA to this person rather than 2 for here. And because of the way this happens, you will occasionally get somebody here where, because of the mixing and matching, you don't happen to get anything from this particular person. But that means you've gotten more from somebody else. And again, think of picking out, if you have M&Ms in different bundles, picking out randomly.
Can I ask a question?
Sure.
So what you're saying is why, so I took a DNA test through 23andMe, and so I find people that I'm related to that I don't share DNA with. And the reason for that is what you just explained.
Right.
Yeah.
And later on, I'll get into, where is it there are actually ways to look at it and saying, if you're a second cousin and you're not sharing DNA, that's a problem.
Yes.
If you're 4th cousins and you're not sharing, that's fine.
Yeah, it's all 4th or later cousins, yes.
Right. Yeah, that's why you're getting people where you really don't share anything because the connection's far enough back. And that's one reason you want to encourage your cousins and even your siblings to test, is they may have inherited something different.
Yes, I have 5 siblings. I have not been able to convince any of them to test, but
Yeah. And actually, cousins are usually better for this,
yeah,
because if you're looking at the 4th to 6th cousin range, and actually an aunt and uncle is even better. You're looking at, there's a bigger chance that your aunt or uncle has inherited something from one of these distant ancestors that they share with the, say, 4th or 5th cousin than your sibling does.
yeah. Unfortunately, I have no aunts or uncles or first cousins.
Yeah, I have that on my mother's side of the family, and it's very difficult.
Yeah.
Um,
Thank you.
so, and this is also the reason sometimes, when you have that, my couple greats grandmother was a Native American, and it doesn't show up in your ethnicity results. This is also where this happens. The other thing is, a lot of people think they have Native American ancestry that they don't. But if it's, if it's 8 generations back, unless it's on one of these laser-like ones, the straight paternal or straight maternal, if it's back here, you're almost always going to miss it. So let's look at Y-DNA briefly. This is actually my brother's, because obviously I couldn't do a Y-DNA test. And those of you who listened to my presentation on Scotland this morning realize that my name should be McGee, not Jameson, because of an adoption. But what's interesting is the people who my brother most closely matches are named Cummings, Morrison, Haight, and Fahey. And then we've got Gallagher, O'Connor, McHugh, McCullen, Donahue. We do actually have a McGee down here and another Donahue. So what can I tell from this? Well, I am pretty sure that my McGees were from Ireland, looking at that sample of last names. And actually looking at the distribution of some of those last names, not only were they from Ireland, they were from Northwestern Ireland, which is what I knew from the paper trail. And so this didn't show me all that. It did show me, McGee is one of those interesting names because it can be either Native Irish Catholic or it can be Scots-Irish Protestant. And I was pretty sure that mine were the Irish Catholic, because the earliest McGee I have found was Irish Catholic, but this confirmed it for me. And if that hadn't, they give you a summary of where your matches live, and there's Ireland at 64, Scotland at 20, and then the US at 11. Now, before I go any further, I'm going to stop sharing this and go into a different screen, because one of the early, where is it? Why is it not here? Show all windows. There it is. One of the early Y-DNA study projects was actually a man named Dean McGee. And so this is a look. This is the results that he had. And these are all the people who've tested by a number for privacy, semi-privacy reasons. And these are all the markers they're testing. And then these numbers are what they tested. And what you can see is, you can see how things change. Like, these are all people named McGee, and here it's 37, and here it's 36. And so these 3 are the same. And then you have 2 different sets here. And on this marker, some people have 12, some people have 11 or 13, 14, 15. And the more these are alike, the more related they are. And then this one is looking at, so you have the people closely related with no genetic distance, and you've got people who've got, large genetic distances. Like here's one where you've got a whole series where it's a genetic distance of 4 between this person and these matches. This is what you get if on this is at the Y-DNA chart he's done for the project at Family Tree DNA, which is the only place that does Y-DNA. And here he's got it, the oldest paternal ancestor, and you can look, and mine is here somewhere. Here's Bernard McGee. And really I only know his son Francis. I have the name Bernard from his death record, and I'm a little skeptical on that. And what's interesting is he's clumped them, because this is just a visual of, I see the numbers and I go, no, they told me that in library school there'd be no numbers. Why are there numbers on my computer screen? So this is what I understand, and he's clumped them, and so these testers are all fairly closely related. Here's my line. Notice that there's no other person in my line. My McGees are out there, which we saw with no close relationship testing. Here's another clump of who are related, and so on. So this hasn't helped me figure out who Francis McGee was and who his father was. That would be too much to expect, but it does happen for people. I'm not saying don't do it, because I know people it's happened for, but this just gives you an idea. This is the data collectively, and as I said, this one line is my brother's results, and those numbers mean nothing if you aren't comparing them to somebody else, which is why I don't go too much more into explaining what they're measuring, because what you need to know here is, like, looking at this one above him, well, those numbers are the same, but if we get over here, this person has a 24 and I have a 25, so that's one step of genetic difference. Here's an 18 and 16, here's a 10 and 11, and so we're getting to be not closely related when you get that many differences. So I'm going to stop sharing this one and go back to the PowerPoint. Let me get that. Where's it? There we go.
BJ, the charts that we were just looking at, what was the name of them?
This is the McGee DNA project. And basically, a man whose name is McGee started almost 20 years ago convincing McGees around the world to test and to see how related they are.
If I'm further interested in that, though, I can do this offline or later. I'd like to get more information on that, okay?
Yeah, if you just Google McGee DNA study, it'll
Okay.
come up.
Thank you.
Let's see, I want to go back here. All right, do you have my PowerPoint again? Okay.
Yes.
So let's take a look. So what does this mean genealogically? And so if you've tested 37 markers, which is really the minimum you want to do, you get too many false positives with smaller tests. If you have a genetic distance of 0, there's a 90% chance your common ancestor is within the last 5 or 6 generations. But you'll see here, if you're looking at a genetic distance of 2, which is what my closest is, you're looking at 12 generations as the closest, as when you're likely to have a common ancestor. So you're looking at 300 to 400 years. But here's the problem. This is my line, although we have since added my new nephew Timothy here. To get a relative that's fairly certain, we're looking at 12 to 14 generations, and I'm back 5. And so, there's this gap between what I know and what I can connect to. Now, if this were like my mother's line with the records in New England going back to the 1600s, I might well be able to prove something with this. But because it's my dad's Irish line, the records pretty much peter out at this point. Okay. So Y-DNA is really helpful for some things, but it's still limited in what it can do. And if you've had a test done at Ancestry, 23andMe, or MyHeritage Family Tree, what you had done is an autosomal test. So that's what I'm going to spend the rest of the time talking about. What do you get from this? You get an ethnicity estimate. At Ancestry, you get what they're calling genetic communities, and I'm going to explain that. We'll talk about the relatives next week, which is really, in some ways, the meat of what you want for genealogy. 23andMe does some health reports about certain, like the BRCA gene, whether you have one of the markers that's one of the ones that has people at higher risk of breast cancer. So if you've got breast cancer in your family, it's worth knowing whether it's the kind that's related to the BRCA gene, because it puts you at higher risk of breast cancer and ovarian cancer and all of that. Ancestry started doing that, but I haven't done it there, so I can't tell you much about it yet. They've just started it. So the ethnicity. Ethnicity is what a lot of people do this for. It's fun. At the continental level, it's almost certainly right. If it says you have Asian ancestors, Native American ancestors, African ancestors, European ancestors, they've got that pretty much down. Within Europe, what they've got is within you see these 3 big circles on this map? They've pretty much figured out Eastern European DNA indicators from Southern European, from Northwestern European. But within each of these circles, don't worry if you get things you aren't expecting. There was a lot of back and forth around this part of the Mediterranean. And they're not digging up people from hundreds of years ago to test their DNA to be the reference population they compare your DNA to. What they're doing is, looking at, they're going to a little town in Norway and finding people whose grandparents were all born within 25 miles of there. And they're going to a little town in Italy and doing the same thing, which is great, except like my dad's sister, all 4 of her grandparents were born within 25 miles of Edinburgh in Scotland. But for them, several of them had grandparents that were born in Ireland. And so it's really hard in some cases. There's enough back and forth that they're still working at figuring this out. The other issue is, and I'm not sure if it's changed, I've heard it's changed, but I haven't looked into it, I need to. For quite a while, consumer genetic testing has not been available in France. And if you look at the map of Europe, having that data not in the pool removes a big chunk of information. So just picture that France is not part of this testing, and you can see how they have some trouble getting all of this figured out. And there was a lot of back and forth. I mean, the Danes and the Angles and the Saxons came from this area and settled here. You had people from here settling along here, over here in Ireland. You had people moving around in here. So basically, if you're expecting only Northwestern Europe and you get, 15% Greek, that's worth thinking about. Is there something in your paper trail that's not right? But if you're expecting only United Kingdom and you get Dutch or Norwegian, it may just be a fluke. The other thing is anything under about 1.5% to 2%, you generally, and certainly under 1%, for your purposes, consider it genetic noise. So, if you're 0.8% something, it's probably coincidence and not a real trace. Although I'm going to show one thing in my results and my brother's that may actually be a real trace, but I've got a reason for believing that. So ethnicity, they do update their ethnicity estimates. So this is my brother who tested at Ancestry for me. I paid for it. And basically, they've tinkered with their reference populations, but essentially it basically says that my family is all from Northwestern Europe. What's interesting is, this little tiny bit that I said to ignore, he and I have that at all the services that we've tested, 1% to 2% of something that's not from the UK or Ireland, and something that my aunt on my dad's side doesn't have. And I have a mystery ancestor on my dad's side, or on my mother's side of the family, shows up in Massachusetts in 1815, marries a local woman, has 2 kids. He goes off on, he's a mariner, goes off on a voyage to the West Indies and dies. So he's right at the number of generations that should be the 1.25 to 1.5% DNA. And because he's a mystery, I actually have solid reason to think that there may be something, and I don't know whether it's West Asian, Jewish, or whatever. That I'm not sure on, but it's showing up, and you'll see that in other of the results. The other thing that Ancestry does, you'll see here they've got these dots that are solid, and then they've got the dots with a dotted line, a dashed line around it. What this is doing is this line is the straight genetic information. That's just looking at their reference populations. For the England, Scotland, and Wales, or England, Wales, and Northwestern Europe, Ireland and Scotland, Norway. The ones here that have the dotted lines and don't have an estimate, this is their attempt to combine the DNA with all the family trees they have to figure out where your ancestors were. The DNA is looking 200 to 800 years back, or attempting to. This is attempting to really look at 200 years ago. Where were your ancestors in about 1800? And yes, a lot of the trees have mistakes, but they're hoping that the volume of data is smoothing out the problems with the trees. And so as you can see, Scottish Central Lowlands, that's the borders. Here you have my mother's side of the family. Again, a lot of them Northern England. So you can see how, they've got Europe West, and then they've got England, Wales, and Northwestern Europe. And then this one's Ireland, and then they merge Scotland and Ireland together. Those are changes in those reference populations. Here is a closer look within this. So it's saying that with combining the DNA and the family trees that they have, New England settlers, which is my mother's family, they were all here practically by 1650 in Massachusetts. And so that's their attempt to use they have 10 million people who have tested with their DNA. They have millions of trees. And so they're trying to use all of that huge amount of data to come up with this prediction. And in my case, most people I know who have this say it's pretty accurate, and it certainly is in my case. So this is at 23andMe. And what's interesting is this looks like I have a lot of Eastern European, but again, it was that 1%. And so when they updated, you'll notice they got rid of that, and I'm back to Northwestern Europe. So this green here correlates to a green line you can barely see there. And so this is this is my brother, and these two are me. And as you can see, there's this tiny little bit that keeps showing up. And the different services chunk their reference populations differently. And so here, this is my heritage, and this is me, and this is my brother. And you'll see we both come out at 98 point something % European. But his little weird thing is Middle Eastern, mine is West Asian. Who knows why the difference, but we're still getting, as I said, he and I are consistently getting that little 1 to 2% that I think may be coming from that mystery ancestor, who I think may have come from Portugal or Spain based on my latest research. But you'll see some of the breakdown. He's got different DNA than I do. They're updating theirs again soon, is my understanding. They've updated their reference population. So I'll be interested to see how that works. So what I'm going to do now is, I've reached the end of the ethnicity. I'm going to talk about it for a minute more, and then we'll do questions. And then next week I'll talk about the relatives, because that is the, for genealogists, that's where a lot of the real meat of DNA comes from. So yeah, the ethnicity is getting better. It's much better than it was 5 years ago. It's still a bit of a parlor trick. So those Ancestry commercials where the guy switches from a kilt to lederhosen or vice versa is silly, because they really aren't quite at the point for the most part of pulling that detail out effectively enough to be that definitive. Now, on the other hand, there are certain things, there are certain ethnic groups that married within their group, and so that is easily pulled out. French Canadian ancestry, those of you who listen to my Quebec, your most French Canadian ancestry is from 10,000 or so people who immigrated to North America in the 1600s and didn't really mingle with anybody else for 3 centuries. And so if you've got French Canadian ancestry, that should show up. If you've got Ashkenazi Jewish, that should show up as an ethnic group. If you have certain Mennonite, if you have the Anabaptist, Mennonite, and Amish, that will show up. Certain island populations will show up as a specific group that's pretty reliable. So there was I should find the article and send it to you guys because it was an interesting read. Woman tested expecting to be 100% Ashkenazi Jewish, and she was either 25 or 50% Irish. And at a similar time, another woman tested expecting to be 100% Irish, and she turned out to be either 25 or 50% Ashkenazi Jewish. And it turned out they ended up figuring out that it was either the father or the grandfather was switched at birth. The fathers or grandfathers were switched at birth in the hospital in New York City. And they figured it out through the DNA because, you know, Ashkenazi Jewish is enough different from Irish that that's something that you'd begin to say, yeah, there's a problem here. So, you know, again, if you're expecting 100% Italian and you get 15 or 25% Irish, that may mean that one of your couple your grandfather or great-grandfather wasn't who you expected. But you'd want to then work through the relatives to make sure on that. And that's why I'll devote all of next week's session to the relatives and how to work that information to figure out what the DNA is really telling you. Okay. So questions. It's a lot of information. I am going to put these slides up at Dropbox or at the State Library website when I figure out how to do that, and I will send them to you. So after next week's program so that you have it. I also have a handout that I will put up on DNA. Actually, let me see if I can find it while I'm answering questions. So, any questions at this point? Okay, I'm putting the resources thing in the chat so you can get that.
BJ, would you suggest then on Ancestry that if you've got brothers that they should do yours because like you and your brother did to see that expands your information?
Siblings are great, cousins are better, or at least as good. Cousin, you know, basically if you're really getting into this, you want to get as many people tested as you can. If brothers are what you have, you know, for the autosomal, it doesn't matter, brother or sister.
Okay. No, I said it because I have done it, and that's how I have found cousins, even distant cousins.
Right.
On both sides. Yeah.
And if you don't have other close relatives, your sibling will have inherited different stuff. And you'll have overlapping matches, but you won't have complete. With the autosomal, because of that 5 to 7 generation thing, anyone who has a parent or an aunt living, or further back, grandparent and great aunt, it's worth getting them tested if they'll agree to it, because they're further back and closer to those earlier ancestors, and you'll get back a further generation. Yet, Lucy, I'm seeing your question. I will talk about the law enforcement stuff next week.
Okay.
And because once we do the relatives, more of that will be clear. And I want to, you know, I could answer it now, but I think it'll be, the answer will be better after I've talked about the relatives.
Okay.
Okay?
Yep.
Because that's what they're using.
Yeah.
They're not using the ethnicity. It's not reliable enough for that kind of thing.
Okay.
And there are answers to that and ways you cannot have it be a problem.
I thought so.
And Ancestry is the best on that. I will give you a preview,
Yeah.
and I'll explain why next week. So I had my dad's sister, who's the only surviving member of that generation, tested, because I can then look at the matches at Ancestry that she and my brother share, and they need to be on my dad's side of the family. And the matches that we don't share are almost certainly on my mother's side. At least for anything close enough, fourth cousins and in, that's, and so I've been able to do that sorting. And I'll talk a lot more about that next week. I tend to start people with Ancestry, and next week I'll talk about the drawbacks to Ancestry. But for people just starting out, it's the easiest website to use. And so if you've got family, siblings and cousins who just want the basics for fun, it tends to be the cheapest. It's the largest database. And you as a genealogist can start looking at stuff. And I'll talk next week about what they're lacking, but how to get around that. But the basic thing I wanted to get you to see today is that you don't need to be intimidated by the science. You're really looking at numbers, and the bigger the numbers in the case of autosomal DNA, or the smaller numbers for genetic distance, are all that really matters. And you can, the relationship of the ethnicity, it's fun, but that's the fun part. It's not necessarily, unless you get one of those cases like the Irish and Ashkenazi Jewish that are so different, it's not going to help you on a genealogical level. But it's what people have heard of, so that's why I start with it.
Mm-hmm.
Does that make sense to everybody?
Yeah.
So, yeah, on the adopted, yeah, you're doing the, if you're adopted, you want to do the autosomal, because that's capturing some from all the ancestors rather than just your straight maternal line or just your straight paternal line. I would recommend for male adoptees doing Y-DNA as well at some point, if autosomal doesn't do anything for you relative-wise, but really the autosomal is going to be what helps you the most. Yeah, endogamy is exactly what I was talking about with island populations. Endogamy is where a group marries within, the gamy is for marriage. So you have polygamy is, one man marrying many women. And endogamy is marrying within a group. And so that's where you get the French Canadians, you get the some island populations, you get Ashkenazi Jews, things like that. And that'll be more clear next week as we talk about relatives and how to look at it. But you do get, in some cases, in a lot of cases, you get better ethnicity results as well, because those groups have limited genetic diversity. Okay, let's see what else have we got. In deep roots, hundreds of years. That's pretty much what this is kind of looking at. They're still working on the deep roots and connecting it to modern stuff. This is, this science. My dad was one of the first people to do a consumer DNA test back in 2004 when you could only do Y-DNA.
Cool.
It's actually an interesting story. My mother was in the late stages of cancer that finally killed her. And I went to visit them for Thanksgiving. My mother asked me, what did I want for the winter holiday present for Christmas / Hanukkah / whatever. And my dad was a scientist. And so I said to him, well, there's this new thing called, it's Y-DNA testing. And now he was a physicist, not a biological scientist, but he read Science magazine. He had an interest in the general scientific process. And it was quite expensive still at that point. Quite a bit more than they would have normally spent on a present for me. But I showed him the piece of paper that I'd printed out about the test. And at this point, my mother was so immunocompromised that he was trying to not go anywhere if he didn't have to. And she ended up dying about 3 weeks after this. He looks at the paper, looks at me and says, does this mean I don't have to go to the mall to buy something? And I went, yes. And he said, sold, and went up to the computer to buy the kit. I think he would have done it even if my mother hadn't been sick, just because he was enough of a scientist that, and I have since then, the company we did it with merged with some others. And so I did a couple years ago, had my brother do a Y-DNA test again at Family Tree DNA, which is much more stable than these old companies. At that point, there were like 3 or 4 companies doing it, and all but Family Tree DNA have dropped out of the market. And I can tell you with confidence that my brother is indeed my father's son. My brother and I match our father's sister right at the amount we should. The aunt and niece and nephew relationship. I've had people ask me, and my father was a week short of his 35th birthday when he got married. And if it turned out we had an older sibling, half sibling that we didn't know about, that would not, one from after he got married would bother me, because it would shake my father was absolutely devoted to my mother. And you talk about winter holiday presents, a couple years, 2 or 3 years after my mother died, I asked my dad what he wanted for Christmas, and he said, well, the one thing I want, you can't give me, meaning my mother back.
Oh.
So, a younger half sibling would bother me. But an older one, I'm sort of half expecting it every time I go in, because hasn't happened, but I'd be a little bothered if I found out my father knew about the baby and didn't do anything about it. But if it's a case where many of these, the father's finding out that he didn't know about the baby for some reason, when people are finding half siblings. So there are surprises, but it's having members of your family test, and especially the downside of a sibling testing is you can't then use those test results to sort your maternal from your paternal side if one of your parents isn't alive to test, which is why a parent sibling is the next best. And I paid to have my aunt take a test, and she was happy to. I was named for her, so she kind of has a soft spot for me. And so would have done it anyway, but but then after that is a first cousin, and that will help you. And then a second cousin helps you figure out which of your 4 grandparents somebody's related to. So that's the summary of the ethnicity and what DNA kind of is and what they're measuring. And for what we're doing, this is all the raw data doesn't help. The ethnicity, the company's comparing it to this the reference population, and next week when we talk about relatives, you're comparing to other people. And so it's comparing to other people that's the important thing. So yeah, so I put up the genetic genealogy resources list, if you haven't seen it in the chat. And it lists a couple of the blogs I follow. My two favorites are the genetic genealogist, Blaine Bettinger, and DNA Explained by Roberta Estes. They're both in there. I mentioned a couple podcasts that are more true crime related. So they're looking at some of the, how the DNA has been used on, for law enforcement, and some other resources. The Blaine Bettinger's book originally came out in 2016, and an updated version came out in 2019. So if you're going to buy it, spend the money to get the 2019 and not the 16. Enough changed that it is worth the extra money over, you know, for a new copy of that rather than a used copy of the 2016. This is recording, and I will be putting this up at YouTube. So if you know anybody who's interested and missed it, when I do the email for next week about what's happening, I will put a link to the YouTube. So if you know anyone who's interested and wants to come to the second session, they'll be able to listen to this session at YouTube, because the second half won't make much sense without some of what we talked about tonight. So with that, I'm going to stop the recording.